Hi everybody, so today we're going to be talking about different eye conditions, specifically nearsightedness and farsightedness. And what I'm going to do is I'm going to talk about what normal vision is and some structures of the eye, and then we'll talk about what happens when you're nearsighted or farsighted. So let's go ahead and get started. And first thing I'm going to do is I'm going to draw the eye, so that would be like the cornea right there. All right, and then we're going to have the rest of the eye. I'm going to draw my ciliary body with my ciliary processes, my suspensory ligaments. I'm not going to put the iris or any other structures up in here and there. And so this is going to be my lens, okay? Then back in here, I'm going to have my retina, okay? If you remember, the retina is made up of rods and cones. And then in the retina, I'm gonna make this look like it's pointing out towards you, but in actuality, it'll be pointing that way. We're looking at the eye from the side, but to make this make more sense, it's gonna look like it's facing out towards you. So we're gonna have a structure that's known as the macula, and the macula is going to have a larger concentration of rods and cones. And then in the center of the macula, we're going to have another structure, which is actually it's like a little pit that would be in here. But I'm just going to draw it like this. And this is going to be called the Fovea Centralis. And the Fovea Centralis is actually just made up of all cones. And it's the highest concentration of cones, so we get our best vision. So normally what happens is our lens tries to focus things onto the Fovea Centralis. So let's talk about what's going to happen in normal vision. So in normal vision, first of all, we call this Aemotropia, right? And this is normal vision. And what's going to happen is light rays are going to come in, and the lens is going to focus them right on the Fovea Centralis. So here comes my light rays. And this is what's going to happen in normal vision. So light rays are focused on the Fovea Centralis. All right, so that's normal vision, Aemotropia. Okay, so let's take a look now of what's going to happen when we have nearsightedness. So let me just erase some of this real quick. And it's going to look something like this. So we're going to have my macula and all that back in shape and my Fovea Centralis. What's going to happen in nearsightedness is first we're going to call this myopia, right? So in nearsightedness, it's called myopia. And in this case, these light rays are going to cross in front of the Fovea Centralis. So light rays cross before the Fovea Centralis. Light rays cross before Fovea Centralis, okay? So now, why? There's a few things. As we get older, the lens becomes less flexible, so it's not able to adapt to close and near objects as much as it can in a younger person. Or you may get something called astigmatism. And in astigmatism, the shape of the eyeball changes. So what can happen sometimes, if the eyeball becomes longer, it moves this whole Fovea Centralis and macula away from the lens. So the light rays are going to cross in front of this, right? So that's what's going to happen in myopia, right? We get astigmatism or we get something wrong with the lens, light rays cross before the Fovea Centralis. Oh, and here's what the person does then. If this is where my light rays are and I want to see an object, I need to bring it closer. As I bring it closer, I move these light rays back onto that Fovea Centralis, right? So I bring it closer, these go back onto the Fovea Centralis, and now I can see the object. So let's talk about what happens in the opposite case, in farsightedness. Okay, so here's what, first of all, farsightedness is going to be called hyperopia. In this case, you're farsighted. Right, so now my light rays, they'll never cross, they'll never come together. And technically, if they were to come together, they would come together after the Fovea Centralis. Now I'm drawing this outside the eye, but technically they just never cross, right? Because they can't go through the eye. So in farsightedness, I'm going to get the opposite, right? I'm going to move an object away so I can move where these light rays cross forward so they can be on the Fovea Centralis. So I can focus those on the Fovea Centralis. I move it away, and now I can see. So in farsighted, light rays meet, behind the fovea centralis. And like I said, technically they're never actually going to meet because they can't go outside the eye and do that. So just to reiterate, so in normal vision, light rays would come and they basically meet on the fovea centralis. In nearsightedness, light rays meet before the fovea centralis, and so we got to move things closer to the eye to push that back onto here. In farsightedness, the light rays would meet behind the eye if they met at all, and so therefore I got to move objects away so I can focus it on there. So that's basically it for vision and vision problems. Thank you so much for watching. If you liked the video, please hit the like and subscribe button, and we'll see you next time.